Okay, this is Coach Schaefer. This is a recording of notes that we are going to be taking on February 27th, 2020. So, yesterday we should have done graphs of scatter plots over certain data. So, for instance, we did one that was height and shoe size, one that was battery, your phone battery, versus how many hours ago you charged it. And the third one was your birth date and your birth month. So with that, what we did was when we plotted these scatter plots, we essentially took the set of bivariate data. Bivariate data means that we used two variables and then found a relationship between them. So for instance, we found that with the shoe size, the taller you were, the larger your shoe size. With the phone battery, it was the longer it had been since you charged it, the lower the phone battery. And then we found that with the birth date versus birth month, there was no association. So a scatter plot is a graph, points plotted to show the relationship between two sets of data. A cluster is a set of closely grouped data. Data may cluster around a point or along a line. An outlier is a data point that is very different from the rest of the data in the set. And an association describes how sets of data are related. We could also call that correlation. So we notice that with a positive association, such as with the height and shoe size, that we're going to have a positive upward trend. With negative association, like with the phone battery, we notice that we have a downward trend. But with no association, we can neither graph a positive or a negative line because there's no real definition or any defined place for us to put it. So we can't say that because the points are so random and so scattered, we can't say that there's a positive trend, and we also can't say that there's a negative trend. We can also just use common sense to find when there's no association. So, how can we describe the association from a scatter plot? Well, Juan recorded the shoe size and the math test scores of several students. The scatter plot shows what he recorded. Describe the association between test score and shoe size. So if we look at the data, it's kind of random. There's really no positive trend. There's also no negative trend. We can't really definitively say that's positive, and we can't definitively say that it's negative either. It's kind of in between. It's just random. We can also, if we just think about it, do you really think that your shoe size determines how you do on a math test? I don't think that's a realistic expectation. Your shoe size does not determine what you make on a math test. So then we can therefore say that this data will have no association. Now, for example 2, this is where we're actually going to create a scatter plot of the data. So we look at the data that we have. Okay, we see height, we see weight, then we see height, and we see weight again. So this is actually it's not two different ones, it's actually all one table, but they split it in half to more easily fit it in a small area. So we should be able to go from height, and then weight, and weight. So when we make the data, what I'm going to do is instead of making a large graph and having to plot really small data, because this data would be tightly grouped together and it'd be so close that I wouldn't be able to get a good read on it, what I'm going to do is I'm going to make a interval graph. And so what we're going to do is we're going to draw our graph. We're still going to have an X and we're still going to have a Y. But instead of starting at 0, 0, I'm actually going to choose my lowest height. So my height is going to be my X values. My weight is going to be my Y. Same thing here, X and Y. So my height's going to go on the X, weight's going to go on the Y. So we can say that the weight is going to go to my y. So we're going to start with 50. And then I think the best thing for us to do is, could we go from 50 to 68. So what I'm going to do is I'm going to go by, let's go by twos. So we're going to go 52, 54, 56, 58, 60. Then 62, 64, 68, and last one being 70. Then on the y, we're going to go by the weight. So our lowest weight, looks like the lowest weight is 83, the highest weight is 103. So I'm actually going to start here. This first point is going to be 80. So right here, so this now, instead of being 0, 0, it's going to be 50, 80. And then I have to go from 80 to 103. So I'm also going to go by twos. So we have 82, 84, 86, 88, 90, 92, 94, 96, 98, 100, 102, 104. So now we're just going to plot the points. So this will be my x, this will be my y. So we're going to go to 50 weight, 50 height, 83 weight. So at 50, we'll be at 83. So that's 82, 83. Then we'll go to the next point. 53 and 90. So we'll be at 53, so it's 52, 53, and then we'll go up to 90. Then next point is 56 and 86. So we're going to go 56, 2, 4, 6, and then 86. That's 88, 86. Then 57, 92. So 52, 54, 56, 57, and then 92. 92. So about right there. Then 60 and 98. 60 and 98. 65 and 97. So 62, 64, 65. Go to 97. And 65 and 103. So 62, 64, 65, 103. Let's be about right there. And the last one being 68 and 100. So 68 and 100. Now if we notice from this, it's not really random. They're not like we have a high, low, high, low, high, low, high, low. We can see that there's going to be a positive upward trend. And if we think about it, it makes sense that the taller you are, the more you would weigh, if you want to stay proportional. Now, yes, you are going to have some people who are going to be really tall and really skinny, or you're going to have some people who are going to be really short and will weigh more. But for the most part, when we think about it, the taller you are, the more you will weigh. So we can say, therefore, that this is a positive association. Positive association. Now, next, we need to describe the types of association you see between the height and the weight. And I want you, in your own words, to explain. So we know it's going to be positive association. And then what I would like to do, what I'd like you to do, is from what I've just said, I want you to explain, in your own words, how you would describe this association and why. Now, if we move on to example number 3. Okay, so example number 3. We have a scatter plot over here. And if we pay attention to the title, it says annual movie attendance. Age is my X. Number of movies is my Y. So if we look at the vocab above, it says a cluster is a set of closely grouped data may cluster around a point or along a line. So we can look at the clusters we have. So we should notice that there are two clusters. One right here, we'll call that cluster number 1, and another cluster right here, we'll call that cluster number 2. So then I want you to describe that. Well, we can say, for instance, that cluster number 1, we notice that it's at lower x and lower y values. So maybe we can say that cluster 1 would be that when you are younger, you don't watch as many movies every year. So cluster 1 lower x and y values. Whereas cluster number 2, we can identify cluster number 2 at higher x and higher y values. And we can even say that maybe when you get older, you have a tendency to watch more movies every year. So this makes sense because if you think about it, when you were younger, you probably didn't watch as many movies because your parents maybe didn't want to go out to the movies as often because they didn't want to have to take you to the bathroom constantly, or if you cried or you got bored or anything like that, you wouldn't go out to the movies as often. And then plus, it's harder for you to focus when you're younger, so on and so forth. But then as you get older and your attention and your ability to take in what you're seeing increases, then you'll want to watch more movies because you'll find it more entertaining to you as you get older than maybe you did when you were younger. Now, of course, we're going to find outliers, and outliers are a data point that is very different from the rest of the data in the set. So if we notice, we should have 1, 2, 3 outliers. So we could say that maybe we have an outlier. Outliers are at 12, 12. So I'm just doing the coordinates of them. We have another outlier at 22 and 15. And the third outlier we have is at 24 and 9. So what that means is that when they were 12 years old, they only saw 12 movies that year. When they were 22, they only saw 15 movies that year. And when they were 24, they only saw 9 movies that year. Now, outliers can be described, and we can identify them because they're not near the other cluster of points. So if we just look, we should be able to tell, like, hey, this is nowhere near the cluster. This is kind of close, but it's still far enough away that we can call it an outlier. And then this one is nowhere near any of the clusters. Okay, now while this might be closely to, like, if we were to draw a trend line, it would look something like this. It would be a positive line going this direction. So this might fall near the line, but it's far enough away from the clusters for us to consider it an outlier. So there could be many reasons for these outliers, such as maybe when you were 24 years old that year, that 24-year-old, maybe they got a new job, they couldn't afford to go to as many movies, whatever it may be. Maybe when they were 12 years old, they just weren't interested in movies, maybe they like to watch TV shows. I don't know. But whatever the reason for those outliers are, there are still these outliers. And that's how we would describe them, is because they're not near the clusters. So that concludes notes for today. And I hope that y'all can follow along, do whatever. Again, you can pause whenever you need to and pay attention and rewind, so on and so forth. So now that we're done with notes, I want you to go ahead and fold this, glue it into your notebook, and you're going to go to the sub, get the worksheet from the sub, and you're going to work on the worksheet. Thank you very much.